Today's topic is curve sketching using the derivative. We're going to be drawing some really cool cubic functions today, and we're going to be using the derivative. So if you don't know calculus, pause the video here, jump into one of our calculus videos, come back, and you'll be able to do this topic. So let's review the basic parabola, y equals ax squared. And I want to talk specifically about the gradient function. So if we have y is equal to fx as our function, the gradient function y dash is equal to f dash of x. So let's look at the gradient at multiple points throughout this parabola. So if we look here, we can see that the gradient looks something like that, which is a negative gradient. So we can say here that f dash x is going to be less than 0. We have a negative gradient. What about if we look right here, right at that vertex point? Well, we actually have a flat gradient and we say f dash x is equal to 0. F dash x, the gradient is equal to 0. Let's look at this point over here. We have a positive gradient, so we can say f dash x is greater than 0. So what happens in a parabola? We start with negative gradient, gradient becomes 0, and then we have our positive gradient. So there's a new terminology. This brings us to the idea of increasing, decreasing, and stationary. So at this exact point here, the graph is stationary. Y is not changing. The y value stays flat. So we can say here that at f dash x is equal to 0, the graph of y is stationary. Let's look over here when we have a positive gradient. So at this particular x value, we have this particular y value. If we go across by, say, 1 on the x value, and we come up, what has happened to our y value? The y value has increased. So when we have a positive gradient, we know that the function is increasing. So increasing is when the gradient is positive, and it's the opposite on the other side here. So the y value for this point and the y value for an x value across by 1, as we can see, we decreased. So here we would say the function is decreasing. So positive gradient means our function y is increasing. Negative gradient means our function y is decreasing. And zero gradient means our function is stationary. So this leads us into the idea of stationary points. And that's the first thing we need to know. This point here is stationary. There are three main types of stationary points. We have what we call a maximum stationary point. As you can see, the graph comes up to a max point and then it comes back down. Over here, we have a minimum stationary point. The graph comes down to a minimum point and it continues back up. Over here, we have a horizontal stationary point. Now, ignore this for now and we'll come back to this in a later video. So today we're just looking at the maximum and the minimum stationary points. Now that we know the two types of stationary points that we can have, we can try sketching them when we're given a curve. So if we look at the function y is equal to x cubed minus 3x squared plus 3, how would we sketch this using the derivative? So we know earlier, we saw that these stationary points, this point here and here, they happened when the gradient was stationary. They happened when f dash x was equal to 0. So what we can do is we can use this as a rule. If we take the derivative and set it equal to 0, we can solve to find the stationary points. Let's try doing that. The first thing we need to differentiate this. So this becomes 3x squared. This becomes minus 6x, and the constant disappears. So I have my gradient function, my y dash. Now I need to set it, equate it to 0. So solving this, I factorize out a 3x, and I'm left with x minus 2 is equal to 0. And solving further, using null factor law, I get x is equal to 0, and x is equal to 2. So I've just solved that my gradient is equal to 0 when x is equal to 0, and when x is equal to 2. So I'm going to have two stationary points for this graph. Now, these are just x coordinates, they're points. I need to know what the y value is. So really quickly, I can sub in x is equal to 0. That gives me a y value of 3. And when x is equal to 2, I'm going to get 8 minus 12 plus 3 is minus 1. So I've got a point here and a point here. But are they maximum or minimum? Are they a max turning point or a min turning point? Turning point, by the way, is another word, another way of saying stationary point. So is it a maximum or is it a minimum? We need to use something called the first derivative test. So to determine whether we have a maximum or minimum for these turning points, let's use the first derivative test. What that means is we want to test what's happening around the x value in terms of gradient. Because if I have a negative gradient, then my zero gradient, which I'll have at these stationary points, and then a positive gradient, I know I have a minimum turning point. If I have the opposite, where I have a positive gradient, a zero, and then a negative gradient, I know I'm going to have a maximum turning point. So let's test this point 0, and I'm going to test on either side, so point -1 and point +1. I want to see what's happening on either side. When x is equal to -1, my gradient is going to be 3 times 1 is 3, plus 6 is going to be 3 plus 6 is 9, so I get a positive, so positive. When x is equal to 0, I get 0 minus 0, so 0. And when x is equal to 1, I get 3 minus 6, which is negative, so negative. So I can see, at this point here, I get what looks like a maximum. So this is a maximum turning point at the point 3, 0. So I can put that here on my graph, and I know it's going to be a maximum. Let's test this next point. So x and y dash. I want to test the point 2. So on either side, I might try 1 and 3. Now we know when x is equal to 1, we get a negative. We've already done that, so we can save us some time. When it's 2, we get 3 times 4 is 12, minus 12 is 0, so we get 0. And when it's 3, we get 27 minus 18 is a positive. So we have what looks to be a minimum turning point. All we need to do now is plot this next point, 2, -1, there. So my graph is max, down into min, up like that, and down like that. Now, I didn't calculate my intercepts, so the intercepts may be a little bit off, but I just want to show you the shape of y is equal to x cubed minus 3x squared plus 3. That is how we would graph this equation. So, where do we go from here? Well, we know that this is a max turning point here, and this is a minimum turning point here. When we change from a max to a minimum, something is happening in here, and we call this a point of inflection. Now we'll cover that in the next video, so let me know in the comments if you guys had any questions about anything we taught today. Hit that subscribe button. Would love to have you guys join our community, and check us out on TikTok. We post videos there every day, and I'll catch you guys in the next one.